All right, so this is the first new concept in this unit. And our goal is I can determine the exact values of trigonometric ratios for special angles. So we're talking about exact values in 4.1. And what we mean by that is using geometric properties, it's possible to determine the exact value of certain angles. Okay, and what I mean by exact values, so far what you've done is you've taken your calculator and to find a ratio of this, for instance, the sine of 45 degrees, you type that in, and I actually will do that as soon as I bring up a calculator and make sure my mode is on degrees. Yes, it is. And so if I actually took the sine of 45, up comes decimal 70710678812. Okay, and it goes on, and that's all my calculator gives me. That is an approximate answer. Okay, it's not an exact value. Actually, the exact value is 1 over the square root of 2, which you're thinking, what? Yes, so we're going to actually come up with exact values for certain angles. Not, it doesn't work for all angles, but it happens for certain angles. So let's take a look at the angles it will work for. Okay, so first of all, we're going to look at a triangle that consists of 90, 45, 45, okay, angles. Okay, so that's the first thing I'm going to do is I'm going to label that. So that means obviously I already have the 90, so that's 45, and this one also is 45. Now this is a special triangle. Not because it's a right angle triangle, but because it is an isosceles triangle, which means that this side has to equal this side. Okay, that's what isosceles means. So the first thing I'm going to do is I'm going to assign the number 1 to my side lengths. So that's the first step I'm going to do. And I'm going to type up the stuff here in a second. So now I have side length 1, and I can actually, using geometric properties, find the length of the hypotenuse. Because it is a right angle triangle, I know that the c squared equals b squared plus c squared. We know that. So I'll bring up my pen, equals a squared plus b squared. So I have 1 squared plus 1 squared, which equals 2. So the side length of c is square root of 2. Okay, so knowing that, what I can do is I can find the sine of 45 using this information. So the sine of 45 degrees, and if I just quickly label my triangle, and it doesn't matter which 45 I use, but I'm going to use this one. So this would be my opposite. Obviously, this is my hypotenuse, and this is my adjacent. So the sine of 45 would be opposite over hypotenuse. And the cos of 45 is adjacent over hypotenuse, which actually turns out the same thing. So if you actually took your calculator, the sine of 45 and the cos of 45 are the same number. And I know tan of 45. Remember, tan is opposite over adjacent, which is 1 over 1, which equals the number 1. So I actually have exact values, trig ratios for that. Now, one thing I'm going to do, however, because in mathematics, even though they've taken this part out of the curriculum for grade 11, grade 12, you're supposed to be able to do it. We don't like to have a root sign or radical sign on the bottom. So what do I have to do to get the root sign off the bottom? I would have to multiply both the top and bottom by root 2. And by doing that, and I just have to do it for the sine and for the cos, by doing that, I get root 2 over, what's root 2 times root 2? Well, that's the number 2. So that's what we end up having. That sine of 45 really is root 2 over 2. Okay, so these are the exact values for sine of 45, cos of 45, and tan of 45. So when they ask for exact values, and I know it's a 45-degree triangle, what I am going to do is, and I'm just going to demonstrate the way I do it, is I create my triangle very quickly. I have a 90-degree triangle, 45. Side length 1, 1, and this I can calculate square root 2. Okay, so I create this and then I do the sine of 45, cos of 45 based on that triangle I've drawn. Okay, so if I get 1 over square root of 2, that's acceptable. However, it is much better if it's root 2 over 2. So that is the exact value of 45-degree angles. Then what happens is we have another um, set of angles we can look at, and that is um, a 90-degree triangle with 60 and 30. Okay, so that equals 180. Now, in order to do this one using geometric properties, I'm starting with an equilateral triangle. So an equilateral triangle means that all sides are equal, all angles are equal to 60 degrees. And what I'm going to do here is I'm going to make, because we know they're all the same, I'm going to make each side length 2. Okay, now so far I don't have a right angle triangle, so what I'm going to do is I'm going to drop a perpendicular bisector down. So perpendicular bisector, what that means is it creates, perpendicular means it's creating a 90-degree angle, but bisector means that it actually has cut it in half. So that's one property of a right angle triangle, of an equilateral triangle. When I drop a perpendicular bisector, it cuts it in half. So let's take a closer look. I said side length was 2, so that means the side length of part of this is going to be 1. And I'm just trying to get my pen to go down where I want. So this is side length of 1 based on that. So what I'm going to do now is I'm actually, because I have the information I want, I just want to take a picture of the right angle triangle. Okay, so I'm just taking a picture of this triangle. And there it is. And I'm just going to take this and I'm going to shrink it, group it, shrink it so it's a little bit out of my way. So this is the triangle I'm looking at. I created it by starting with an equilateral triangle. Now for some reason my number 1 disappeared on me, but I will put it back in there. Okay, so that's side length 1. Now to find this other side, I have a few things that are going on. And one thing I should have mentioned when I said a perpendicular bisector, it actually created a 30-degree angle at the top as well. Okay, so when I cut it, it cuts the angle, it cuts the sides, everything gets cut. So this, using Pythagorean theorem again, however, this time I know the hypotenuse, so the side that I'm looking at this time is going to be created by going with 2 squared minus 1 squared, okay, which is the square root of 3. Now, I know all 3 sides, the exact values of all 3 sides. Now I can label the triangle according to 60 or to 30. Okay, now usually I just memorize the one triangle. Well, actually, I don't even do that. I just memorize that I have an equilateral triangle, side length 2, perpendicular bisector 1, and I can figure everything out that way. So now if I look at I don't know why I was put C, if I want to find the sine of 60 degrees, well, the sine of 60 is opposite, which is square root 3, over hypotenuse, which is 2. The cos of 60 is the adjacent side, which in this case is 1, over the hypotenuse, which is 2. And that little line shouldn't be there. In fact, let's make it disappear. And then if I look at the tan of 60, it's opposite over adjacent, which is root 3 over 1, so that's root 3. So that is using this triangle to find the sines of the angle 60 and cos, and tan. I can use the same triangle, but this time for the angle 30. So the sine of 30 is going to equal opposite, which is 1 over hypotenuse, which is a half. The cos of 60 equals the square root of 3 over 2. And finally, the tan of 60 is going to be the opposite over the adjacent, which is root 3. Now, just like when we did the 45, we don't like the root 3's on the bottom, so we're going to change that, multiply top and bottom by root 3, and we end up with root 3 over 3. Okay, so that is exact values for those. So what are they going to expect you to be able to do? Well, a few different things. So let's go to the next page. Determine the exact values of the following. Bracket tan of 45 degrees minus sine of 30 degrees equals, and all of that squared. Okay, so the first thing I need to do is I need to have those triangles to look at. So this again, remember what I told you I did? So, and isosceles triangle, 45, side length 1, 1. This is square root 2. That's all I need to know. I have an equilateral triangle, side length of 2. Cut down to 1, and this would be a 30-degree angle, and this is square root 3. Okay, so if I remember some of those aspects of it, I can always find the missing side using Pythagorean theorem. Okay, so the tan of 45. Okay, tan 45. Tan is opposite over adjacent. So that's 1 over 1. Sine of 30, here's 30 here, which is 1 over 2. And then I'm supposed to square that. So I really have 2 over 2 minus a half, so I have what, half squared, which equals 1/4. No problem. Okay, next one, sine squared 45 times cos squared 45. What it means when it has that squared part, it means that I'm supposed to take the sine of 45, I'm supposed to take that answer and square it. So that's really what this means when you see this. Okay, oops. I want the square outside there. Okay, so let's again do that. I have the two triangles I'm looking at. So 45, okay, so I'm looking at 1 over the square root of 2, and I want to square it. And I'm going to multiply by the cos of 60. Here's 60. The cos of it would be adjacent over hypotenuse, and I want to square that as well. So I end up with 1 over 2 times 1 over 4, which equals 1/8. Okay, so there's some work in your textbook as well as a worksheet, just so you get used to doing this. Okay, have fun. It's not that bad.